Sometimes our code is going to fail. It might be our fault for making a programming error, or it might be an end user using our system in a way we didn't anticipate. Sometimes it'll even be hardware failures. And a lot of errors can't really be attributed to any one single source. But they are going to happen. And the way that our program handles the error case is often just as, if not even more important, than how it handles ideal use cases. In this video, we're going to take a look at Java exceptions. By using Java exceptions, we can detect, catch, and in some cases recover from errors that occur within our program. While we go through exceptions, there's something really important to keep in mind. Exceptions are called exceptions because they exist to handle exceptional cases. Things that we either couldn't handle or couldn't anticipate when originally writing our code. Exceptions modify the control flow of our program, but we should never use them for anything other than catching and handling or passing exceptions. If we attempt to use them to implement logic, we'll make a program that quickly becomes very confusing for us and is immediately very confusing for any other programmer who attempts to understand it. To help us explore Java exceptions, I've set up a basic program that can fail for us to play with. It's an eternal loop that does two real things. First, it takes input from the user using our scanners.next float function, and then it prints that input back out to the user. If we properly give this program floating point values as input, it will run, theoretically, forever. But if we make a mistake and give this program a string as input, the next float function will not know what to do with that, and an exception will occur. When this happens, we get all this red text in our console. This red text is actually going to the system.err for system.error stream. Let's take a look at this text. It has two important sections. The first part of this text, the bit that's not tabbed in, is the identifier for this exception. It lets us know that an exception has been thrown and the basic where, and then it tells us what type of exception has occurred. You'll notice that this exception is found in the java.util path. This looks very similar to if we were importing something into our code or directly pathing to an external library. That's because this exception that's been thrown is actually a Java object. And this piece of the exception method is letting us know exactly what type of object it is. The second bit of this exception test is what we call a stack trace. And it's basically the pieces of our program that Java has jumped through. At the very bottom of our stack trace is where the exception was originally thrown. That's scanner.java, line 909. That's not our code. That's the code written for scanner.java, presumably where the next float method lives, or code that the next float method calls. Stack traces are the layers of code. So once the input mismatch exception occurred, Java just began jumping up layers of code, or bracketed areas, until it eventually reached the top layer where our code resides. That's exception.java, the file we're in right now, and it's the top of the stack trace. Exception.java, line 11, is the last place where Java was able to handle or throw up this exception. Once line 11 was reached and the exception was still propagating upwards, there was nothing else to handle it because this is the top of our program. So the exception wound up getting printed to our system.err stream and our program terminated with result 1, which is a failure case. This is great for debugging purposes. We know right where to go to figure out what went wrong in our program. Exceptions.java, line 11. But If we were creating a program that we were looking to release for some reasonable purpose, we generally don't want our program to crash whenever a minor error occurs, especially an input error like this that's perfectly reasonable for a user to make from time to time. So let's explore how we can handle exceptions. When Java is told to throw an exception, it stops executing the current code block and begins jumping up levels until the exception is handled. That's how we got from deep within the scanner.java class to exceptions.java line 11, the piece in our code where, as far as we're concerned, the exception occurred. If our code was being executed by another block of code, because we do not handle this exception, instead of printing out to system.error right here, we'd simply throw the exception up another level, and they'd see exception.java line 11 in their stack trace. But sometimes it doesn't make sense to keep throwing an exception. Sometimes we want to handle the exception case because we know what to do with it, or because, as in the case we're dealing with right now, there's a lot nicer ways to inform the user of what went wrong than this stack trace and exception name. Additionally, if we handle this exception here, there's no reason that we can't resume our while loop as though nothing had happened. One failed case of this while loop isn't necessarily reason to terminate our program. If we're going to handle exception cases, we're going to make use of the try-catch code blocks. In any block of code where we think an exception might be thrown, and we'd like to handle the exception, we're going to wrap that line of code in a try block. For the most part, this doesn't affect how this code is executed unless an exception occurs within the try block. If an exception is thrown within the try block, instead of propagating that exception upward to the next level, the code within the following catch block is going to be immediately executed. Catch blocks require a little more information before they can execute, though. They need to know what exactly they're catching. We can catch all exceptions by simply catching anything of the exception class, but that may not be a fair thing to do. There's a lot of different schools of thought on exception handling, but generally people will agree that you should only catch and handle exceptions that you, to some degree, expected might occur. In this case, we happen to know that an input mismatch exception is thrown if we give invalid information through user input. Because we're going to be printing out a message when this exception occurs that specifically tells the user, you passed invalid input, we certainly don't want to be catching any exceptions that are not input mismatch exceptions. So now, if we actually, let's put in the new line to this code block 2. And now if we run our program with our try catch block in place, and let's quickly test that it works in the good use case as it did before. And now if we cause that input mismatch exception to be thrown by providing string input, we should see our catch block execute, and we should get the you passed invalid input response. Now, as you can see, we do get that response, But unfortunately, we're getting that response over and over and over again. We've inadvertently introduced an even worse bug. Now, instead of throwing an exception and crashing, our program just enters an infinite loop. Here's why. Our scanner object is a stream reader. That means there's a buffer of input that it picks to read from. In the normal use case, our user is adding floating point numbers to that input, and we pick one out, and then we execute and go back and wait for another. However, when a string is found in there, this line of code throws an exception, which is fine because we catch it with our catch block. Our catch block prints out the new line of text, and we go back to the beginning of the while loop. But that bad string in our reader's buffer is still there. So when we catch our exception, we need to clear out that stream. Fortunately, this is something we can handle. Once we've caught and handled our exception, let's clear our stream reader by simply grabbing its next line and doing nothing with that information. That will flush this line from the reader. If we run our program now, we'll see that it handles and recovers from a failed input where we give it a string, which is pretty cool. Let's go over a couple more things we can do with exceptions though. For one, clearing out our reader at the end of an exception case makes a lot of sense. But it might make even more sense to clear out our reader at the end of any attempted case. After all, we're entering this while loop with the assumption that there's no new line in the reader. When we'd like to always execute a case, no matter if we did or did not succeed in our try block, we can follow our catch block with the finally block. The finally block executes no matter what, whether an exception was or was not caught. And its reason for existing is so that you can put cleanup code in your system. An example of cleanup code is clearing out our reader here so that there's nothing there to confuse ourselves later or other programmers. Exceptions are more than a simple object that gets thrown. They can contain a lot of really important information. As we saw earlier, exceptions can contain a stack trace. Let's quickly modify our program so that while it still gives user-friendly uPassed and valid input information, we also print out the stack trace so that a programmer can debug our program. Generally, when we're writing finished code that a user is going to utilize, we never want a case where they're going to see something as in-depth as a stack trace. It's confusing for most computer users and can be a security risk in some instances. But as a feature in a debug mode or for developers, detailed exceptions like this can be very useful. The exception class exposes a method print stack trace, which requires as input a stream. We've been using system.out for all of our output so far, so we'll provide the print stack trace method with system.out as its stream. Now when we run our program and give it a bad string, we get our initial friendly exception text code, but we still have the stack trace so we can see exactly where our errors are coming from. As I mentioned earlier, exception handling is an extremely deep topic in modern software development. But at the end of this video, you should have a firm hand on the basics, and when you come across exceptions in code or when you're writing your own code and feel that you need exception handling, you should be well prepared. See you next time.